So, in the last class, we have seen Boolean algebra. In this lecture, we will study standard forms of Boolean expression, minterm, maxterm, SOP and POS, all of these things. First of all, be careful with bars, which means that x bar y bar is not equal to xy whole bar, right? So this is not same. But if you have xy whole complement, we can write like this with De Morgan. Now let's start with standard forms of Boolean expression. What does that mean? Why we need standard forms? You can see same Boolean expression you can express in different ways, right? A same expression you can express in different ways. For example, all of these expressions can be written like this. See, so same expression you can write in all different ways. So you need some standard or we can say a canonical way, right? For example, if you see this expression f equals to a plus b, after some time you can see the same expression you can write in different ways. If you notice this expression a, b, and truth table of this a comma b. So this is 0 0, this is 0 1, this is 1 0 1 1. So every row of this input combination, every row of the input combination that we write in the order of their binary value. So this is the standard truth table. So this is your expression a plus b. The same expression you can also write like this in these three situations, right? So you can say that this function a plus b is 1 if and only if a equals to 0 or b equals to 1, or a equals to 1, b equals to 0, or a equals to 1, b equals to 1. So this is plus 1, this is plus 1, right? Now a equals to 0, b equals to 1. How to write this? How we write this? Means a bar b1, right? a1 b0, a b bar. Here a also 1, b also 1, a b, right? So f equals to a bar b plus ab bar plus ab. So you can see that same expression you can write in different way, right? So we need a standard way to write an expression, right? Two more points about it, that it is so derived from the truth table and generally not the simplest form. So for example, if you have two variables, then how many different functions are there? For two variables, how many different functions are there? So for n variables, you have these many different functions. So for two variables, you'll have 2 power 4, which is 16. Right? For n, these many, because these many rows will be there, 2 power n, and for every row, the function can be 0 or 1, right? So if you have same Boolean expression that you can write in many different ways, and if you don't follow some standard representation, so that is the idea. So if you have two variables, then there can be 16 functions, right? So you can see what is this function. F0 is simply 0, F1 xy. This is your and actually F15, if you can say, then this is 1. F14 is NAND. Now for F5, you can see 0101, which is same as Y. 0101, right? Same as Y. Now F6, this is the exclusive OR. What is F3? That is same as X. 0011, like this. So like this you can write many functions. So what are the standard forms? These are the two standard forms. One is SOP and one is POS. Sum of products and products of sum. Okay. So these are the two standard forms that we have and we have to study. So let's start. So first of all, let's see some definitions. So see, a literal is a complemented or uncomplemented Boolean variable. For example, A and A bar are different literal. But this is not a literal. A bar plus CD. Literal means a variable or its complement. See, this is the definition of literal. Complemented or uncomplemented Boolean variable. This is not a Boolean variable. Okay? This is not a literal. In this you have three literals. But this is not a literal. Right? Now let's see the next thing. What is a product term? Product term. Multiplication. Right? That is basically, it means that and of literals. Two or more literals. Right? So I can say that single literal or two or more literals and. So what is the product term? For example, this is a product term, this is the product, all of these are product term. But this is not a product term. So what is a product term if you notice? It means multiplication. And of literals. Or a single literal. This is the definition of product term. For example, this is a product term. This is a product term. All of these. This. This is a product term. Similarly, A, B bar, A bar. It is basically and of literals. Is this and of literals? No, this is not and of literals. Is this product term? No, this is not and of literals. But this is product term. Right? And of literals or a simple literal. So what is product term? and of literal or a single literal. Now after some time, now sum of literals or sum term, which is or of literals or a single literal. Single literal. For example, this is a sum term, 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 right? But this is not a sum term. This is not a sum term, right? This is not or of literals, right? So this is not a sum term. Now this is a sum term over here. Now A plus B plus C complement. Now A plus B plus C complement. Right? Now is this is a sum term? No, this is not a sum term. This is also not a sum term. Sorry, this one. Sum term is very simple. But this is a sum term. This is not a sum term, but this is a sum term. This is what I want to tell you. So sum term basically means a single literal or of two or more literals. Now what about this one? A plus B plus C. Is this is a sum term? No. This is a sum term. Right? A plus B bar. This is not a sum term. For example, A B plus B C. Is this a product term? This is not a product term. What is a sum term? What is a product term? The definition is very simple. Now let's move. What is sum of product? So SOP. What is this concept? Sum of product. The name itself is telling you. SOP. Sum. Sum means or not addition of product terms. Of product terms, right? This is the idea. Which means or of product terms. So these must be over here product terms. like this. These all should be product terms. These are the SOP forms. Now same thing you can do for POS. What is POS? Product of sum, which is and. Product means and of some terms. S1 product of S2 with S3. This will be the POS form. Okay. So here this is sum. Here this is sum and these are products. So this is sum of products. Sum of products. Right? Over here see, this is product of sum expression. POS. Right? Look at this. Is this product of sum? Tell. How? See. Because this is simply your A plus B plus C. Product of sum only. This is product of sum. Right? This is a sum term. Right? So this is a product of sum. You can think like this. What can you say about A plus B plus C? This is your expression. Is this expression in SOP? Or is this in POS? This is in SOP also and this is in POS also. Because this is sum of product. And this is product of sum. Right? This is sum term. This is the product term, product term, product term. Right? We are talking about forms. Forms of expression. Talking about forms of same expression. This and this expression are same but different forms. We are talking about forms of the same expression. Right? So these two expressions are same but they have different forms. Different forms of same expression. Okay, so expression A, this same expression if I write like this, A plus AA or AA. So is this an SOP? Two forms. Right? This is an SOP form. This is sum of products. This is in POS form. No. Why? Because if you do like this is not a sum term. So this is not a sum term. So what is sum term? Sum term means summation of literals. This is not a literal, right? Summation of literal. This is a literal, but this is not a literal. So this is not a sum term. This is in POS. You can think like this. Product of sum, right? This is POS. Is this an SOP? Tell me. If you think like this, yes, this is an SOP also. Sum of product. So this expression is POS also and SOP also. So the definition is very clear. So this is not in POS form over C. This expression A plus BC, not in POS form, right? But over here A plus B, this is in POS also and this is in SOP also. A plus B and A plus B, right? We are talking about different forms of same expression. For example, this expression is not in POS form, but you can write it in POS form. This is not in POS form, but now it is in POS form. For example, this is not in POS, right? But this form over here is in POS. For example, if I write like this, ABC whole bar, BC, this is a whole bar. This is not in SOP, but A bar, B bar, C bar, this is now in SOP form. Sum of product. So that's all for this video. We'll meet in the next class.